So in today's lecture, we are going to see Introduction to Thermal Engineering. This is your unit 2. Okay. Now see, we are going to see basic laws of thermodynamics, and along with that, we are going to see Introduction to Heat Transfer. The three mechanisms by which heat transfer takes place. They are nothing but conduction, convection and radiation. So initially we'll see the basic concepts of thermodynamics. Now see, what is energy?
Energy is the capacity to do work.
Excellent. Energy is the capacity to do work. Now see that energy exists in different forms like work energy, heat energy, right? Now see, work energy, it is denoted by W, and heat energy, it is denoted by Q. Tell me what is work? What is mechanical work? If displacement is not there, can I say that work is there? So how we calculate work? Yes.
Force into displacement.
Excellent. We calculate work by the formula force into displacement. So when we apply force on an object, let's say this is the object which is resting here. If I apply a force F and if it moves by a displacement, let's say X or let's say dx, so that F into dx is nothing but the work done. Or if the displacement is X, I will say that F into X is nothing but the work done. Right? So when the particles move by a distance, we say that work is done. Right? Work can be done by the system or work can be done on the system. Okay. Now, what about heat? Let's say here the temperature is, let's say at this point, the temperature is 100 degrees Celsius, and at this point, the temperature is 50 degrees Celsius. What will happen? Yes. Let's say inside my room the temperature is, let's say right now the temperature may be 18 or 20 degrees Celsius, or let's say it is 21 degrees Celsius, and outside my room let's say that the temperature is 30 degrees Celsius. So when I open the door, what will happen? Yes, there will be flow of which energy? Which is the energy which flows due to temperature difference? Can anyone tell me?
Heat
Heat
energy.
energy.
Heat
Yes,
energy.
heat energy flows due to temperature difference, right? See, heat naturally always flows from high temperature to low temperature. All of you, do you agree with this? That
Yes, sir.
naturally heat will flow from high temperature to low temperature. Okay. Now see, heat flows due to temperature difference and work is caused due to displacement. Right? Heat flows due to temperature difference and work is caused due to displacement or motion. It need not be linear displacement. It can be rotary displacement as well. See, in case of shaft work, we say that whenever rotation is there, work is there. Right? So the displacement need not be right. So work is due to displacement or motion. Right? Now see, heat is a low grade energy. Heat is a low grade energy and work is a high grade energy. See why we call heat as low grade energy? Let's say this is a container in which water is there. And if I heat this container, what will happen to that water molecules? Let's say there is a container which contains water. And when you heat that container, what happens to the molecules? Yes, randomly they will start moving in any direction. They will move in a haphazard manner. They will move in a random direction. So will there be any orderly motion or disorderly motion of the molecules?
Disorderly.
Excellent. There will be disorderly motion of the molecules. And let's say this is object. I am pushing this object. Right? This is experience some force. Now see, or let's say take example of expansion process. All the particles, they are exerting a force on this piston wall. Right? Now see, work is there. Whenever work is there, let's say this shaft is rotating. So if you take any particle on shaft, it is performing an orderly motion, no? Tell me, are you getting?
Yes,
Yes,
sir.
sir.
So
Yes, sir.
always remember this. This is a very important concept that heat is low grade energy because it is due to disorderly motion of the molecules, and work is high grade energy because it is due to orderly motion of the molecules. Right? Disorderly motion and orderly motion. If you take example of a marketplace, there is disorderly motion of people, and if you take example of marching of soldiers, it is an example of orderly motion. Right? So definitely in orderly motion the energy is high grade energy. As work is due to orderly motion of molecules, it is high grade energy. And heat is due to disorderly motion of molecules, it is low grade energy. Tell me very honestly, is this concept clear to you? So which is low grade
Yes, sir.
energy, which is high grade energy?
Heat is a low grade energy and work is a high grade energy.
Very good. Tell me why. Why heat is called as low grade energy and why work is called as high grade energy?
Because it has disorderly motion of the molecules, hence heat is called a low grade energy, and work has orderly motion of particles, molecules, hence heat work is called a high grade energy.
Excellent. Very good. So is it clear to all of you?
Yes, sir.
See, we have seen two concepts. First is that work is due to displacement or motion. Then heat flows due to temperature difference. Right? Then heat is called as low grade energy because it is due to disorderly motion of molecules, and work is called as high grade energy because it is due to orderly motion of molecules. Now see, heat is denoted by Q. The symbol for heat is Q and the symbol for work is W. Right? Both are the forms of energy. Heat is also a form of energy, work is also a form of energy. I believe that this concept is clear to you. Now let us understand what is system, what is surrounding, and what is boundary. Can anyone tell me what is a system?
It is the part of universe
Excellent. It is a part of universe. Can you complete the statement? Yes.
in which observation are made.
Excellent. It is the part of universe in which observations are made. Means what? System is the part of universe which is selected for study. Right? The part of universe which is selected for study. Let's say I am designing a car. So for me, car will be a system. But if someone is designing only steering mechanism, so for him that steering mechanism will be a system. If someone is focused only on the oil which is used in steering mechanism, so for him the flow of that oil will be a system. See, system is the part of universe which is chosen for the study, where observations will be made. For example, for principal sir, this college will be a system. For head, department will be a system. Right? For a class teacher, that total class will be a system. Right? So whatever part is chosen for the study, that is called as system. Tell me very honestly, is it clear to you?
Yes, sir.
Yes, sir.
Yes,
So
sir.
system is the part of universe which is chosen for study, where observations will be made. I repeat, system is the part of universe which is chosen for study, where observations will be made. Okay. Now, what is surrounding? Yes, what is surrounding? Everything in the universe other than system is called as surrounding, because system plus surrounding is equal to what?
Universe.
Universe. So there is a simple equation, system plus surrounding is equal to universe. System plus surrounding is equal to universe. So everything in the universe other than the system is called as surrounding. Now tell me, what is a boundary?
The wall that separates the system and surroundings.
Yes. Boundary is the thing which separates system from the surrounding. Boundary is a thing which separates system from surrounding. See, boundary can be fixed or moving. I repeat, boundary can be fixed or moving. It can be real or imaginary. It can be real or imaginary. Okay, anyway, what is a system? Yes, just repeat the definitions of system, universe, and system, surrounding, and boundary.
It is the
System
part
is
of
a part
universe
of universe in which observations are made.
Yes, that is about system. So system is the part of universe in which observations are made. I believe that this definition is clear to you. Good. What is surrounding?
In the universe, the other than system are called a surrounding.
Very good. Whatever is present in the universe other than the system, that is called as surrounding. Okay. What is boundary?
It is a wall that separates the system from surrounding is called a boundary.
in universe other than system is surrounding.
Okay, so one has told the definition of surrounding and one has told the definition of boundary. Okay, fine, both definitions are correct. Surrounding, anything in the universe other than system is called as surrounding, and boundary is the thing or wall which separates system from surrounding. What are the types of boundary? Yes, what are the types of boundary? See, it can be, yes, can anyone tell?
Real and imaginary.
Excellent, real and imaginary. Excellent, very good. And second type? See, it can be fixed or it can be moving. Okay, boundary can be a fixed boundary or it can be a moving boundary. Now see, there are three types of systems, right? We have seen that system, thermodynamic system is the part of universe under thermodynamic considerations, right? See this word thermo means heat and dynamic means power or work. So this thermodynamics is a science which deals with the interactions between heat and work. Okay. Anyway, now see, as far as thermodynamic system is concerned, what is thermodynamic system? It is the part in which observations are made, right? Or it is a part of universe which is chosen for the thermodynamic analysis. Okay. Now tell me, what are the three types of a thermodynamic system?
Open system, closed system, isolated system.
Excellent. There are three types of thermodynamic systems: open system, closed system, and isolated system. Now see, this is a vessel, right? Where this is open vessel, right? Now see, when this vessel is heated, or let's say this vessel is containing hot fluid. So now see, this vessel can have heat interactions as well as mass interactions with the surrounding, right? Now see, if you enclose this vessel, right? If you put something on this vessel, it cannot have mass interactions with the surrounding, but till it can have energy interactions with the surrounding, right? And if you place some insulation, if you place some insulation over this vessel, right? It cannot have heat interactions with the surrounding, and as it is enclosed, it cannot have mass interactions with the surrounding, right? So there are three types of systems. First system is the system which can have mass interactions or heat interactions with the surrounding. Second system can have heat interactions. Heat is nothing but energy. So second system can have energy interactions with the surrounding, but it cannot have mass interactions with the surrounding. And third system, it can neither have mass interactions nor have heat interactions with the system, right? So tell me, what is open system?
It is a system have mass and heat interaction with surrounding.
Yes. Open system is the system which can have mass interactions as well as energy interactions with the surrounding. See, this first system is called as open system. It can have mass interactions as well as energy interactions with the surrounding. What is closed system? Yes, what is a closed system? What is a closed system? Yes.
Closed system is a system that energy interaction with surrounding but does not have mass interaction with surrounding.
Yes, excellent. Closed system is the system which can have energy interactions with the surrounding, but it cannot have mass interactions with the surrounding. Excellent. Very good. Can anyone tell me what is isolated system?
Isolated system is a system that have neither have mass interaction or energy interaction with surrounding.
Excellent. Isolated system is the system which cannot have mass interaction or energy interactions with the surrounding. For example, thermos flask, right? It is enclosed, so it cannot have mass interactions with the surrounding, right? And there is some insulation on the thermos flask. That's why the tea remains hot, right? So it cannot have energy interactions with the surrounding. So that is an example of isolated system. So tell me, these three types of systems, is it clear to you? So what are the three types of systems? Yes,
Open system,
Open,
closed
closed, and
system, and
isolated.
isolated system.
very good. Now see, this is open system because it can have, let's say tea is boiling in this vessel. So it can have energy interactions with the surrounding as well as mass interactions with the surrounding, right? So where energy and matter, sorry, where energy and matter are exchanged, that is called as open system. What is closed system? Can you call this as closed system?
Yes,
Yes.
sir.
Why?
Yes.
Mass
In
Because it has
interaction.
only
energy
energy.
only
Yes,
change,
it has only
exchange.
energy
Matter
interactions
does
with
not
the
exchange.
surrounding. Yes, very good. It has only energy interactions with the surrounding. It cannot have mass interactions with the surrounding. Pressure vessel is the example of closed system because it cannot have mass interactions with the surrounding. But yes, it is having energy interactions with the surrounding. Thermos flask. Which type of system is this?
Isolated system.
Isolated.
Isolated.
Yes, this is isolated system because it cannot have mass interactions or energy interactions with the surrounding. So I believe that this concept is clear to you. Three types of systems: open system, closed system, and isolated system. Now see, there are different laws of thermodynamics. For example, first law, second law of thermodynamics, third law of thermodynamics, and zeroth law of thermodynamics. So we'll see one by one. What is zeroth law of thermodynamics? If two bodies are in thermal equilibrium with a third body, then the two bodies will also be in thermal equilibrium with each other. Let's say these are the two bodies, B and C, right? They are not in contact with each other, but B is in thermal equilibrium with A and C is also in thermal equilibrium with A, right? Then what we can say? We can say that B is in thermal equilibrium with C. If two bodies, right? It can be any two bodies. If the two bodies are in thermal equilibrium with a third body, then we can say that these two bodies are in thermal equilibrium with each other. Tell me very honestly, is it clear to you?
Yes, sir.
So what is the statement of zeroth law of thermodynamics?
If two bodies A
If
and
two
B are
bodies
in
A and
thermal
B are in the
equilibrium with
thermal
third body
equilibrium
C, then
with
two
third
bodies
body
A and
C,
B
then
will
two bodies
also in
A and
thermal
B will
equilibrium
also
with
be
each
in
other.
the thermal equilibrium with each other.
Yes, very good. So it is very simple. If two bodies, let's say these are two bodies. This is body A and this is body B, right? Now A is in thermal equilibrium with C. Let's say my body is body C. This is body A, this is body B. If I'm folding these two bodies together, let's say A is in equilibrium with C, B is also in equilibrium with C. So I can say that A and B, these two bodies are in thermal equilibrium with each other. So if two bodies, right? If two bodies are in thermal equilibrium with a third body, then those two bodies are in thermal equilibrium with each other. See, it is very simple. If two bodies A and B are separately in thermal equilibrium with a body C, then we can say that those two bodies are in thermal equilibrium with each other. Then we can say that these two bodies are in thermal equilibrium with each other. Tell me very honestly, is it clear to you?
सर
Yes.
थर्मल इक्विलिब्रियम म्हणजे काय?
Thermal equilibrium, I will tell you the concept of thermal equilibrium. Tell me, what do you understand by mechanical equilibrium? मेकॅनिकल इक्विलिब्रियम आपण कधी म्हणतो? When we say that mechanical equilibrium is there, or you tell me what when we say that chemical equilibrium is there? There are different types of equilibrium. What do you mean by mechanical equilibrium?
Net forces acting on a body are zero.
Excellent. So when there are no unbalanced forces, when there are no unbalanced forces inside the system, we say that there is mechanical equilibrium. There is existence of mechanical equilibrium. Excellent. Very good answer given by you. Now tell me, what is chemical equilibrium?
When there is no chemical reactions within the system.
Excellent, excellent. Very good. So when there are no any chemical reactions taking place in the system, we say that there is chemical equilibrium. Now from the same logic and from this name, can anyone tell me what is thermal equilibrium?
There is no
No.
heat.
Yes, there is no any heat interactions. When this is possible, if temperature at this point and temperature at this point is same, will the heat flow from this point to this point? It
No.
is very simple. Heat will not flow from this point to this point. Let's say temperature at this point is also 20 and temperature at this point is also 20. So will the heat flow from this point to this point?
No, sir.
No.
No.
We can say that the system is in thermal equilibrium. So we can say that the system is in thermal equilibrium. See, try to understand. This is a very good question, and I expect this kind of questions from you because that will clear your concepts, and that is the objective behind conducting lectures. Lectures are also available on YouTube. So why we conduct lectures? We conduct lectures so that there will be conceptual understanding. See, let's say this is the object. You are applying force in this direction and
No.
this direction. Let's say if I am applying a force 100 newtons in this direction and 100 newtons in this direction, will this object move?
No, sir.
No.
No. So we can say that
No.
mechanical equilibrium is there. We can say that mechanical equilibrium is there because there are no unbalanced forces. But if this force is 200 and if this force is 100, what will happen?
It will move.
It will move.
It moved,
It will
sir.
move because there is a resultant force of 100 newtons in this direction. So there is no mechanical equilibrium. Right. Similarly, if the temperature at this point is, let's say, 25 degrees Celsius and at this point is also 25 degrees Celsius, will the heat move?
No.
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 We can say that this body is in thermal equilibrium or this system is in thermal equilibrium. But if the temperature at this point is, let's say, 35 and temperature at this point is 25, what will happen?
It will flow.
Transfer.
Yes, heat will flow from this point to this point. So we cannot say that the system is in thermal equilibrium. We cannot say that the system is in thermal equilibrium. So I believe that this concept is clear to you. So I just wanted to show you this zeroth law of thermodynamics. Now see, this is body A, this is body B. Now see, A and B are not in contact with each other, but still we can say that A and B are in thermal equilibrium with each other. This is called as zeroth law of thermodynamics.
सर
This, yes,
आता बोलला ते काय कळलं नाही, रेंज गेली होती. परत सांगता का?
okay,
Yes.
okay. See, if two bodies are separately in thermal equilibrium with a third body, if two bodies are separately in thermal equilibrium with a third body, then we can say that the two bodies are in thermal equilibrium with each other. For example, let's say there are two bodies. This is body A, this is body B. A is in thermal equilibrium with body C and B is also in thermal equilibrium with body C. ए आणि बी ह्या दोन्ही बॉडीज एकमेकाच्या कॉन्टॅक्ट मध्ये नाही आहेत. ए अँड बी आर नॉट इन कॉन्टॅक्ट विथ इच अदर, बट ए इज इन कॉन्टॅक्ट विथ सी अँड बी इज ऑल्सो इन कॉन्टॅक्ट विथ सी, अँड ए इज इन what we can say? We can say that A and B are in thermal equilibrium with each other. This is the statement of zeroth law of thermodynamics. So tell me, is it clear to you?
Yes, sir.
So what is the
Yes, sir.
statement
Yes, sir.
of zeroth law of thermodynamics? Yes. Zeroth law of thermodynamics says that if two bodies are separately in thermal equilibrium with a third body, then those two bodies are also in thermal equilibrium with each other. I repeat the statement, it is very simple. If two bodies are in thermal equilibrium with a third body, then those two bodies are also in thermal equilibrium with each other. If two bodies A and B are separately in thermal equilibrium with body C, right? Then we can say that the two bodies A and B are also in thermal equilibrium with each other. Tell me very honestly, is it clear to you?
Yes, sir.
Yes, sir.
Okay, okay. Now see, what is energy? Energy is the capacity to do work. Unit of energy is joule, right? We have discussed what is thermodynamics, interactions between heat and work. We have seen what is system, what is surrounding, and what is boundary. We have seen types of systems like open system, closed system, and isolated system. I have prepared two PPTs. This PPT is exclusively for laws of thermodynamics. Okay, anyway. Tell me very honestly, any difficulty in zeroth law of thermodynamics?
No, sir.
No, sir.
Okay, okay. Now see, I will just take 2 minutes. I will repeat what we have studied and then we'll move forward. Okay. So we have seen work. We have seen heat. We have seen that work is due to orderly motion, right? So it is high grade energy. We have seen that heat is due to disorderly motion. So it is low grade energy, right? Then we have seen that work exists due to displacement or motion. We have seen that heat flows due to temperature difference. Then we have seen what is system, what is surrounding, and what is boundary. We have seen types of boundary. Then we have seen types of systems, right? Like open system, closed system, and isolated system. And after that, we have seen zeroth law of thermodynamics. See, the law is very simple. It states that if two bodies A and B, let's say these are two bodies A and B, they are in thermal equilibrium with a third body C. Let's say A is in equilibrium with C. A is in equilibrium with C याचा अर्थ काय होतो रे? I will tell you in very simple language. A आणि C equilibrium मध्ये, thermal equilibrium मध्ये याचा अर्थ काय होतो?
A is equal to C.
टेम्परेचर सेम आहे.
Excellent, excellent. Temperature of A is equal to temperature of C. Thermal equilibrium मध्ये म्हणजे या दोघांचं टेम्परेचर सेम आहे. If A is in thermal equilibrium with C, it means that temperature of A is equal to temperature of C. Right? And B is in thermal equilibrium with C. याचा अर्थ काय होतो रे?
B आणि C चं टेम्परेचर सेम आहे.
एक्सलंट. बी आणि सी चं टेम्परेचर सेम. मला सांगा, ए आणि सी चं जर टेम्परेचर सेम असेल आणि बी आणि सी चं जर टेम्परेचर सेम असेल, आय कॅन से नो दॅट टी ए इज इक्वल टू टी बी. If TA is equal to TC and TB is also equal to TC, even if A and B are not in contact with each other, simply I can say that TA is equal to TB. It is as easy as that. If two bodies A and B, आता इथं फिगर मध्ये मी काय केलंय, B आणि C घेतलंय. Okay. So if two bodies B and C are separately in thermal equilibrium with a body A, right? Then these two bodies are in thermal equilibrium with each other. So tell me very honestly, is the statement as well as explanation of zeroth law of thermodynamics is clear to all of you?
Yes, sir.
Yes, sir.
Okay. So see, it is very simple. Okay. So if two bodies are separately in thermodynamic equilibrium with a third processes. Now see, what is state of system? Yes, can anyone tell what is state of a system? Yes, when we say that the system has undergone a thermodynamic process, when we can say that a system has undergone a thermodynamic process, when the state of system changes, when the state of system changes, we say that the system has undergone a process. Okay, when the state of system changes, we say that the system has undergone a process. Is it clear to all of you? थर्मोडायनामिक प्रोसेस झाली असं आपण कधी म्हणतो रे? बरं ठीक आहे, तुम्हाला जे माहिती ते सांगा, मला सांगा टाइप्स ऑफ प्रोसेसेस कोणकोणते असतात रे? Yes, already you have studied all these concepts in your 12th, 11th and 12th.
Isothermal process, isochoric, adiabatic.
Yes, isothermal process, right? Polytropic process, adiabatic process, isochoric process, isobaric process, right? प्रोसेस झाली असं आपण कधी म्हणतो? जेव्हा सिस्टीमची स्टेट चेंज होते, जेव्हा सिस्टीम स्टेट ए कडून स्टेट बी ला जाते, तेव्हा आपण म्हणतो की सिस्टम हॅज अंडरगॉन अ प्रोसेस. स्टेट म्हणजे काय असतं रे? व्हॉट इज स्टेट ऑफ अ सिस्टम? An identification of a system by a set of known thermodynamic properties is called as state of the system. जसं मी तुम्हाला विचारलं की तुम्हाला पीसीएम ला किती मार्क आहेत, तुम्हाला सीईटी ला किती मार्क आहेत, मग तुम्ही सांगता फिजिक्सला एवढे मार्क आहेत, केमिस्ट्रीला एवढे मार्क्स आहेत, मॅथ्सला एवढे मार्क आहेत, मग ती झाली तुमची स्टेट. त्या स्टेटच्या बेसिसवर तुमचे ऍडमिशन होणार. सो तुमचं आयडेंटिफिकेशन कशावर झालं? फिजिक्सचे मार्क, केमिस्ट्रीचे मार्क, मॅथ्सचे मार्क. सो सिमिलरली एखादी सिस्टीम डिफाईन करताना आपण कशी डिफाईन करतो की त्या सिस्टीमचं प्रेशर एवढं आहे, टेम्परेचर एवढं आहे, व्हॉल्यूम एवढं आहे, राईट? सो दिस इज कॉल्ड एज स्टेट ऑफ अ सिस्टम. सो टेल मी व्हॉट इज स्टेट ऑफ अ सिस्टम? I repeat the definition. An identification of a system by a set of known thermodynamic properties is called as state of a system. जर मी तुम्हाला सांगितलं, I'm having a system, let's say there is a boiler, right? In which the pressure of steam generated is, let's say, 120 bar and the temperature of steam generated is, let's say, 275 bar. So you will get an idea, okay, this much enthalpy is there, okay, this kind of steam is there, this much is the temperature and this much is the pressure, right? So tell me, what is state of the system? Yes,
It is an identification of system by its known thermodynamics process is called a state of the system.
yes. See, state of system is identification of a system by a set of known thermodynamic properties. This is called as state of the system. I believe that this is clear to all of you. Okay, now see, whenever this state changes, समजा सिस्टीमचं प्रेशर आहे आता, let's say pressure is 120 and temperature is 275, right? Let's say it is passed through a turbine. So let's say the pressure becomes 2 bar and temperature, let's say it becomes 50 degrees Celsius. So state has changed. When steam is passed through a turbine, the state has changed. So whenever there is change in state of the system, we say that the system has undergone a thermodynamic process. Tell me very honestly, is it clear to you? When we can say that the system has undergone a thermodynamic process? Yes, when we can say that the system has undergone a thermodynamic process?
When system change its state, then we
Yes.
call
Whenever
system is
there is
undergoing.
change, yes, very good. Whenever there is change in state of the system, we say that the system has undergone a thermodynamic process. मला सांगा, स्टेट जर तीच राहिली, प्रेशर तेवढंच राहिलं, टेम्परेचर तेवढंच राहिलं, तर प्रोसेस झाली का रे?
No.
No.
Yes. No. So if state remains same, there is no process. So when we can say that there is process?
Change in a state.
Yes, whenever there is change in state. So whenever change of a system, whenever state of a system changes, we say that the system has undergone process. Now see, there are different types of processes. We'll discuss one by one. Initially, we'll try to understand these names. Isothermal process. Tell me, what do you mean by iso and what do you mean by thermal? Iso means,
Temperature.
yes, if the temperature of system remains same, we say that the system has undergone an isothermal process. For example, ए स्टेट कडून बी स्टेट कडे गेली सिस्टीम, पण ए स्टेटचं टेम्परेचर जेवढं होतं तेवढंच बी स्टेटचं टेम्परेचर आहे. सो वी से दॅट द प्रोसेस इज आयसोथर्मल प्रोसेस, राईट? So the temperature of state before the process and temperature of state after the process, if it is exactly same, we say that the system has undergone an isothermal process. So if temperature of system remains same during the process, it is called as, we say that the system has undergone an isothermal process. So as the temperature remains constant, there will be no change in temperature. So when there is no change in temperature, say delta represents change, T represents temperature. So when there is no change in temperature, if change in temperature is zero, we say that the system has undergone isothermal process. So it is a type of process, right? It is a type of thermodynamic process in which temperature of a system remains constant. Tell me very honestly, is it clear to you?
Yes, sir.
100% there will be objective questions for your INSEM exam which are based on this concept, thermodynamic processes, because this concept is very important. Okay. So what is isothermal process? Yes.
Process in which temperature of a system is constant.
Excellent. The process in which temperature of a system remains constant is called as isothermal process, right? Now we'll see the next type is adiabatic process. Tell me, what do you mean by adiabatic process? Have you heard this word before, adiabatic?
Yes, sir.
See, adiabatic, what is the meaning of word adiabatic? Okay, tell me, what is adiabatic process?
No exchange of heat and mass.
Excellent. The process in which there is no exchange of heat with the surrounding. If Q is zero, if there are no heat interactions between system and surrounding, right? The process is called as adiabatic process. It is a type of thermodynamic process without exchange or heat or mass between thermodynamic system. So if there are no heat interactions between system and surrounding, it is called as adiabatic process. So what will be value of Q for adiabatic process? Q is the symbol for heat. Yes, Q will be 0. Very good. Isochoric process. Tell me, what do you mean by isochoric process?
It is a constant pressure process.
Okay, now see, isochoric. Core means volume. Core चा अर्थ काय होतो? Volume. And see, bar. Bar is the unit of pressure. Now tell me, what is isochoric process?
Volume remains constant.
Yes. If during the process volume of the system remains constant, we say that it is isochoric process, right? And what is isobaric process?
Pressure is constant.
Yes, if the pressure during the process remains constant, we say that it is isobaric. See, isobaric means constant pressure. Bar is unit of pressure. Iso means same or constant. Constant pressure, isobaric. Constant volume, isochoric. No heat exchange, adiabatic. Right? Temperature remains same. Constant temperature process, that is nothing but isothermal process. Right? Okay. So tell me, what are the different types of processes?
Isothermal process, adiabatic process, isochoric process, isobaric process.
Very good. What happens in isothermal process?
Temperature remains
Process in which
constant.
temperature is constant.
Temperature remains constant. Very good. What happens in adiabatic process?
Temperature of Q is constant.
Yes, there is no heat exchange, right? That is called as adiabatic process. What is isochoric process?
Value of the
in
system
which
is constant.
volume remains constant.
Yes, good. This process during which volume of the system remains constant is called as isochoric process. And what is isobaric process?
Pressure constant.
The process
Yes, if the pressure,
pressure is
yes, the
constant.
process in which pressure remains constant, correct, is called as isobaric process. Now we'll see first law of thermodynamics. See, basically, this is law of conservation of energy. Tell me, what is the statement for law of conservation of energy?
Energy can be
Energy
neither be
neither
created
be
nor
created.
be destroyed. It can transfer from one form to another form.
Excellent. See, we cannot create energy. At the same time, we cannot destroy energy. Only what we can do, we can just convert one form of energy into the other form. We can neither create energy, we cannot destroy energy. Only what we can do, we can convert energy from one form to the other form. Now let's say this is a system in which there is piston cylinder arrangement, and inside this piston cylinder there is a gas, right? Let's say initially at volume V1. Now when you heat this, right? When you heat this gas, what will happen? The gas will expand, right? So it will move from volume V1 to V2, right? So it is doing some work, right? It is doing some work. So you are giving heat and it is doing some work. So there is conversion of heat energy into work energy, right? But if we measure heat energy and work energy, it is not same. Let's say we are giving 100 joules of heat to this system, and if it is performing a work of 60 joules, so where remaining 40 joules is gone, the remaining 40 joules is used to increase internal energy of the system. That energy is stored inside the system. That is called as internal energy, right? So simply if I apply energy balance equation, three energies are there. One is heat energy, one is work energy, and one is internal energy. So simply 100 is equal to 60 plus 40, right? Simply I have applied law of conservation of energy. So if this is Q, if energy given is Q, and if energy at the output is, let's say, W and delta U. So what will be relation between Q, W and delta U? Yes. See, if I'm going fast, please let me know. I will reduce my pace. Okay. Let's say there is a system. Am I clearly audible?
Yes,
Yes,
sir.
sir.
Okay. Let's say there is a system. You are giving some heat to the system. तुम्ही या सिस्टीमला हीट दिली, त्यांनी वर्क केलं, राईट? पण त्यांनी पूर्ण हीट एनर्जी वर्क एनर्जी मध्ये कन्वर्ट नाही केली. त्यांनी स्वतःकडे पण काही एनर्जी स्टोअर करून घेतली. त्या स्टोअर केलेल्या एनर्जीला आपण काय म्हणतो? सिस्टीमच्या आतमध्ये स्टोअर झालेली एनर्जी, त्याला आपण काय म्हणतो?
Internal energy.
इंटरनल एनर्जी. मला एक साधं एक्झाम्पल सांगतो तुम्हाला. तुमच्या आई वडिलांनी समजा 100 रुपये दिले, त्यातले तुम्ही 60 रुपये खर्च केले आणि 40 रुपये स्वतःच्या पॉकेटमध्ये ठेवले, राईट? आपण साधं इक्वेशन काय लिहितो? 100 इज इक्वल टू 60 प्लस 40, right? Similarly here, if we have given 100 joules of energy to this system, so Q is 100, right? It is performing a work of amount 60, so W is 60, and let's say its internal energy is increased by 40, because law of conservation of energy cannot be created nor be destroyed. Okay, so remaining 40 joules is stored inside the system, right? So 40 joules is nothing but delta U. So tell me very simple mathematics. If 100 is equal to 60 plus 40, 100 is nothing but Q, 60 is nothing but W, and 40 is nothing but delta U. So can I say that Q is equal to W plus delta U?
Yes, sir.
Yes. So energy at the inlet is equal to energy at the outlet. Energy at the inlet or energy given is equal to energy utilized. Only part of energy is converted into work and remaining part is stored inside the system. So this is the mathematical form of first law of thermodynamics. What is the mathematical form of first law of thermodynamics? Q is equal to W plus delta U. Q represents heat, W represents work, and delta U represents change in internal energy. Tell me very honestly, is it clear to all of you?
Yes, sir.
See, if you are not understanding anything, please let me know what exactly you are not understanding so that I can explain that concept as well. अरे डिस्कनेक्ट झाला होता का मगाशी? येस, एम आय क्लिअरली ऑडिबल?
Yes, sir.
येस सर.
Yes, sir.
ओके, सध्या थोडा इंटरनेटचा इश्यू आहे त्यामुळे मधून डिस्कनेक्ट होतं. तसं काही असेल तर मला सांगा. Okay, so tell me, what is the statement, mathematical form of first law of thermodynamics?
Q is equal to delta U plus W.
Very good. So tell me, what is Q, what is delta U, and what is W?
Q is heat, delta U is
Yes, Q is heat. What is delta U?
change in
Internal
internal
energy.
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 Very good. What is W?
Work done.
Work
Yes.
by the system.
Yes, work done by the system. Very good. So according to first law of thermodynamics, total heat added to a system is equal to the sum of change in internal energy and work done by the system. I believe that the concept of first law of thermodynamics is clear to you. Right? See, there are three statements. This is the one statement. The first statement is first law of thermodynamics is nothing but law of conservation of energy. So what is the statement of law of conservation of energy? Already you have told me. Energy can neither be created nor be destroyed. However, it can be converted from one form into another form. So here, if we are converting heat energy into work energy, right? During this process, also there is some change in internal energy. So we can say that Q is equal to delta U plus W, where Q is the heat supplied. Let's say it is in kilojoules. It can be in joules as well, but generally we take it in kilojoules, right? Delta U is the change in internal energy. Delta means change. Change in, U stands for internal energy. Okay. So delta U is the change in internal energy, and W is the work done by the system. So if I want to find delta U from this equation, tell me how can I find delta U? If Q is equal to delta U plus W, what will be delta U?
Q minus W.
Yes, it will be Q minus W. So tell me very honestly, is this thing clear to you?
Yes, sir.
Okay, so is this equation clear to you? A very simple equation. Q is equal to W plus delta U, where Q is the heat, W is the work, and delta U is the change in internal energy. See, this is called as first law of thermodynamics. This is the mathematical form of first law of thermodynamics. So what is the mathematical form of first law of thermodynamics?
Q is equal to delta U plus W.
Excellent. Q is equal to delta U plus W. I believe that this concept is clear to all of you. Now see, there are sign conventions. There are sign conventions. Now see, what is the sign convention for heat? Let's say this is the system. Heat supplied to a system is positive. See, the sign convention is very simple. As an engineer, what we expect? We expect that we will supply heat to the system and it will perform work. Right? We try to convert heat into work. So heat supplied to a system is considered as positive. आपण एक्सपेक्ट काय करतो की आपण सिस्टीमला हीट देणार, त्यामुळे सिस्टीमला जेव्हा आपण हीट देतो त्याला काय म्हणायचं, त्याला साइन कन्व्हेन्शन कोणतं असेल?
Positive.
पॉझिटिव्ह. आणि मग ह्याच्या जर एक्झॅक्टली उलट झालं, हीट सिस्टीमने रिजेक्ट जर केली तर त्याला काय म्हणायचं? इफ आय एम सेइंग दॅट हीट सप्लाइड टू अ सिस्टम इज पॉझिटिव्ह, राईट? टेल मी व्हॉट विल बी हीट रिजेक्टेड बाय अ सिस्टम?
Negative.
Negative. Always remember this. Heat supplied to a system is positive and heat rejected by a system is negative. Tell me very honestly, is it clear to all of you? What is the sign convention for heat? Yes, what is the sign convention for heat?
Positive.
No, I'm asking you what is the sign convention? Like you should say
Q.
like if heat is supplied to a system, it is positive. If heat is rejected by a system, it is negative. Tell me very honestly, is it clear to you?
Yes, sir.
सिस्टीमला जर आपण हीट सप्लाय केली तर त्याला साइन कन्व्हेन्शन द्यायचं पॉझिटिव्ह. सिस्टीमनी जर सराउंडिंगला हीट रिजेक्ट केली तर त्याला म्हणायचं निगेटिव्ह. दिस इज अ साइन कन्व्हेन्शन. जसं आपण म्हणतो डिस्प्लेसमेंट मेजर करताना, positive direction of x-axis, negative direction of x-axis, positive direction of y-axis, negative direction of y-axis. We say like that, okay? On the same line, there is sign convention for everything. So there is sign convention for heat, work, and internal energy. Let us understand one by one. Let us first understand sign convention of heat. So tell me, in this case, this value of Q will be positive or negative?
Positive.
Positive.
Yes, positive. Why it is positive? Your answer is correct. Very good. Just tell me the
Heat is
explanation.
supplied.
Why it is positive?
Heat is
Supplied
supplied.
to system.
Yes, it is supplied to the system. That's why it is positive. त्याच्या उलट असतं समजा V2 वरून व्हॉल्यूम V1 ला आले आणि त्यांनी हीट रिजेक्ट केली आहे. त्या क्यूला आपण काय म्हणलं असतं? कोणतं साईन दिलं असतं त्या क्यूला?
Negative.
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 Yes, very good. So I believe that this concept is clear to all of you, that heat supplied to a system is positive and heat rejected by the system is negative. Okay, very good. Now see work. Either work can be done by the system or work can be done on the system. So tell me, work done by the system will be positive or negative?
Positive.
Positive. See, work done by the system is positive and work done on the system is negative. तुम्हाला जर मी सांगितलं की वर्कची व्हॅल्यू आहे प्लस 40 किलो जूल्स, सो व्हॉट इज मिनिंग ऑफ दिस स्टेटमेंट?
Work is done
Work is
by
done
the
by the system.
By the system.
एक्सलंट. वर्क इज डन बाय द सिस्टीम. तुम्हाला हे क्लिक झालं पाहिजे की 40 किलो जूल्स एवढं वर्क सिस्टीमनी केलंय. आणि मी जर तुम्हाला सांगितलं वर्क फॉर अ सिस्टीम द वर्क डन sorry, for a system the work done is minus 30 kilojoules.
work is done on
Done
the
on the
system.
system.
Work
Yes,
is done on the
the
system.
work of amount 30 kilojoules is done on the system. वर्क निगेटिव्ह म्हणजे काय? वर्क इज डन ऑन द सिस्टीम. वर्क पॉझिटिव्ह आहे म्हणजे काय? वर्क इज डन बाय द सिस्टीम. राईट? ओके, आय बिलीव्ह दॅट दिस कन्सेप्ट इज क्लिअर टू यू. Right? Sign convention of Q as well as sign convention of W. See, the sign convention is very simple. Heat supplied to a system is positive and heat rejected by a system is negative. Work done by the system is positive and work done on the system is negative. I believe that this concept is clear to you. Is it clear to you?
Yes, sir.
Yes, sir.
Okay.
Yes,
Now
sir.
let us discuss about delta U. Right? So whenever, let's say, internal energy of the system is 100 and afterwards it becomes 200. So delta U is positive or negative?
Positive.
Excellent.
Positive.
It is positive. And let's say internal energy before the process is 200 and after the process is 100. Delta U is positive or negative?
Negative.
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 Energy has decreased. So whenever there is increase in internal energy, it means that delta U is positive. And on the other side, right, when there is decrease in internal energy, I repeat, when there is decrease in internal energy, delta U is negative. So tell me very honestly, any difficulty in the sign convention of Q, W, and delta U?
No, sir.
Tell me, what is the sign convention for Q?
When heat is supplied, it is positive, and when heat is absorbed, it is negative.
See, it is not absorbed, it is rejected. Heat supplied to a system is positive and heat rejected by a system is considered as negative. Yes, tell me again. What is the sign convention for heat?
It is
When
supplied to
heat
the
is
system is
supplied,
positive.
is positive. When heat is rejected by a system, is negative.
Excellent. Heat supplied to a system is positive and heat rejected by a system is negative. Now tell me, what is the sign convention for work?
Work done by the system is positive. Work done on the system is negative.
Excellent. Work done by the system is positive and work done on the system is negative. Now what about delta U? If there is increase in internal energy, delta U is
Positive.
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 If there is a decrease in internal energy, delta U is
Negative.
yes. So this, always remember this, right? Because this is very important. All thermodynamics is based on these sign conventions. Heat supplied to a system is positive. Heat rejected by the system is negative. Work done by the system is positive. Work done on the system is negative, right? Whenever temperature increases, the internal energy increases, right? And when internal energy increases, delta U is positive. When temperature decreases, see the formula for delta U is mCv delta T. The formula for delta U that we will be discussing in next lecture. The formula for delta U is mCv delta T. टेम्परेचर वाढलं की सिस्टीमची इंटरनल एनर्जी वाढते आणि सिस्टीमची इंटरनल एनर्जी वाढली की डेल्टा यू काय झाला पॉझिटिव्ह. ऑन द अदर साइड टेम्परेचर जर कमी झालं तर इंटरनल एनर्जी काय होणार आहे कमी होणार आहे आणि जेव्हा इंटरनल एनर्जी कमी होते तेव्हा डेल्टा यू काय असतो निगेटिव्ह. So tell me, is this sign convention clear to you?
Yes, sir.
So we have seen the sign convention for work and internal energy.